Hey everybody, if you're watching this, you're probably preparing for your Unit 7 test. Real quick before we get started with a quick review of right triangles and solving for sides and solving for angles, here's the equations that you need to know for your test. One that I should add to that is the area of a triangle. I forgot to put that on there for class today, but just so you know, that's also expected of you as well. So those are the equations that you need to know for your test. Now, this is the first half to review. Things like Pythagorean theorem and angle sum theorem, I'm assuming we already know how to do, so I'm not going to go through how to solve those problems like that, because it seems like everybody knows what they're doing on those ones. But we are going to go through setting up and solving for a side length and setting up and solving for an angle. If you notice, all 6 triangles I have on the board are all right triangles, so we can use SOHCAHTOA for these triangles. Right? On the ones on the left, we're going to find side lengths, we're going to find x. The ones on the right, we're going to find theta, which are angle measures. Right? In this first triangle, we know this angle is 30. We want to find x, and 8's across from my right angle, so that makes it the hypotenuse. X is opposite my angle. So I'm going to want to use the SO part of SOHCAHTOA, which tells me I'm going to use sine. So we know sine of 30 equals x opposite over 8 hypotenuse. Okay. Now to solve this, you can take out your calculator, your iPod, whatever tool you have, and to do the sine of 30, and you get 0.5. So that means the left side becomes 0.5 equals x over 8. Now I need to get the 8 off the bottom. In order to get the 8 off the bottom, we multiply both sides by 8 times 8 times 8. 0.5 times 8 is 4, telling me x equals 4. So if I were doing this problem, if they asked me to solve this triangle, right, I knew x was 4. Now I know 2 sides, I can use Pythagorean theorem, and I know 2 angles, so I can use angle sum theorem to finish up. That'll be the case with the rest of them as well. Right? Now the next triangle, here's the angle we know, it's 50. X is my hypotenuse, 10 is the adjacent side. So we want to find our hypotenuse, we're given the adjacent, so we should use cosine. So we write cosine 50 equals adjacent 10 over hypotenuse x. So there's my equation. Now I'm going to solve for x. First thing I do is I need to take the cosine 50. So punch in my calculator, and when you're doing this, make sure that you are in degrees. I don't want to do all the work in radians on our reviews. So cosine 50 is 0.643, keeping your decimal places. It's 10 over x. Now to solve for x, you get x off the bottom by multiplying both sides by x. So the x's over here cancel. So you 0.643 x equals 10. We then divide by 0.643. And we can figure out what x is. So 10 divided by 0.643 equals 15.55. Meaning the hypotenuse of this triangle is 15.55. Excuse me. Now the last one where we're solving for a side length, we're given this angle is 20. This 4 is my adjacent side, x is my opposite side. So we got to use the TOA part of SOHCAHTOA, which is tangent. So tan of 20 equals opposite x over adjacent 4. Okay, so now to solve for this, we do tan of 20 equals 0.364, which equals x over 4. So now to solve, we multiply both sides by 4. And we get 1.456 equals x. That's kind of a cool coincidence. So in all those ones, we solve for our side length x. Now in these next 3, we have 2 side lengths, and we're finding theta. Remember, theta is just a variable for angle measure. So in this first one, we're gonna find theta. Now we got to think about how the sides compare to our theta. So here's the angle I'm trying to find. 3 is opposite it. 6 is my hypotenuse, which means I should use sine, right? Because I'm given my opposite and my hypotenuse. So we do sine of theta equals opposite over hypotenuse. Okay. Now from here we need to get rid of our sine. So in order to do that, we use the inverse sign, or sine -1. If you hit second sine on most calculators, then it'll give you the inverse sign. So we take the inverse sign of both sides. These signs cancel. We end up with theta equals the inverse sign of 3 over 6. Or you can calculate the decimal, which is 0.5, and you can get what that angle is, and it is 30 degrees. So the inverse sign of 3 over 6 is 30, meaning that my angle right here is 30. Now, if they went on to ask me to solve this triangle, we could use Pythagorean theorem to find this side, a squared plus b squared equals c squared, and we could use angle sum theorem to find that one. Do 180 minus 90 minus 30, which would make that 60. All right, this next one, here's my angle theta. 5 is adjacent, 10 is the hypotenuse. So for this one, we are going to use cosine because we're given the adjacent and the hypotenuse. Right? So adjacent and hypotenuse go with cosine, the ka part of SOHCAHTOA. So cosine theta equals 5 over 10. So now I'm going to take the inverse cosine of both sides, which is second cosine on most calculators. So the cosines cancel. We get theta equals inverse cosine of 5 over 10, which ends up being 60. So theta is 60 degrees. And then the last one, here's our theta. 3 is opposite, 4 is adjacent. So now I'm going to have to use the TOA part of SOHCAHTOA. So I'll be using the tan. So tan theta equals 3 over 4. So to solve for this, we're going to take the inverse tangent of both sides. So the tangents cancel out. We end up with theta equals the inverse tangent of 3/4, which is 36.87 degrees. Any questions? Well, you can't ask me at home, but you can ask me tomorrow in class if you have any. Also, while you're doing your reviews, I would keep at least 3 digits on my decimals while I'm doing the work, so like 0.643, 0.364, 0.5. That was a just got 0.5 was a really nice one. So keep at least 3 digits when you're working through the problem, and then your answer keep 1 to 2 digits past the decimal place. But if you have any questions, please talk to me tomorrow in class.